Welcome to this video on graphing quadratics. Primarily graphing a quadratic given to us in standard form, where we're going to need to convert into vertex form, plot the points, draw the graph, and then analyze for some key features. We are going to look at three examples in this video. The first is on the screen. What we need to do initially is complete the square to get this equation in vertex form. In order to complete the square on a function like this, we will write the variable terms first, then leave a little space and write the constant. Now what we want to think is completing the square. What number do we need to put in the parentheses so that when we square it, the first two terms are x squared plus 8x? Well, that'll be a plus 4. And when we square 4, we really get a plus 16, so that the items in this first set of parentheses, x squared plus 8x plus 16, would really be equal to the quantity x plus 4 being squared. But by putting a plus 16 there, we change the value of the expression. So to offset it, we have to put a minus 16 on the side. 12 minus 16 would be a negative 4. So our vertex form, after we've completed the square, would be y is equal to x plus 4, the quantity squared, minus 4. From there, we would be able to note where the vertex of this parabola is. It would be at negative 4 comma negative 4. The parabola would open up because it's a positive number out front of the parentheses, and there's no vertical stretch or vertical multiple to this function. So now we will draw our axes, keeping in mind this parabola is centered at negative 4 comma negative 4. And it's opening up. We will label our axes. Put the first point at the vertex, negative 4, negative 4, over 1, up 1 to both the left and the right, and over 2, up 4 to both the left and the right. Then we'll draw in the parabola, and there's the graph. Now, one of the other items that we will ask for in this scenario is the maximum or minimum point of the graph. In this case, since the parabola is opening up, it would be a minimum point, and that location is at negative 4 comma negative 4, simply the vertex. The axis of symmetry is asking us where would the line be that basically cuts the parabola in half, that creates two symmetric pieces. In this case, that line, the axis of symmetry, is the vertical line x equals negative 4. And the last item that we will consider in this video would be the x-intercepts of our graph. Now we could look at the graph and figure out where the x-intercepts are. It would be the places where the graph crosses the x-axis when y is equal to 0. We have two such x-intercepts, negative 2 comma 0 and negative 6 comma 0. But let's say we wanted to solve for those points without using the graph. The easiest way to do that would be to come back up to our original equation that was written in standard form. And we need to set it equal to 0 because x-intercepts would be the places where the y value is 0. And now, if possible, we can factor that. So two numbers that multiply to be 12 and add to be 8 should be positive 6 and positive 2. We're solving this for where that expression is equal to 0. So on the one hand, x is equal to negative 6. On the other hand, x is equal to negative 2. And at both of those locations, for x-intercepts, the y value would be 0. So that is how we would algebraically solve for the x-intercepts. If the expression couldn't be factored, we could solve it using the quadratic formula or by completing the square. Let's go to our next example. Again, we will begin by completing the square. Variable terms, we write those first. Constant we'll leave on the side. Now, if there's something attached to the x squared, whether it's a number or a symbol, we're going to factor it out. In this case, it's a negative 1. We'll factor out that negative 1 from the variable terms leave some space, and put the constant on the side. Now we will complete the square as we usually would. So inside the parentheses, we would put a -3. That way when we square this quantity, the first two terms would be x squared minus 6x. When we square a -3, we would really have a +9. However, be careful because what we've put into this expression is a -9. So to offset that, we would have to add 9 on the side. -5 plus 9 is +4. So our vertex form equation would be y is equal to negative the quantity x minus 3 squared plus 4. At this stage of the game, we can identify the vertex is at 3, 4. This parabola is opening down because of the negative in front of the squared expression, and there is no vertical multiple to this parabola. So we will go ahead and sketch its graph, being mindful of where the vertex is when we draw in the axes. So we go to the vertex at 3, 4. This parabola is opening down and it isn't having any vertical stretch. So we'll go over 1, down 1 to both the left and the right. And then we'll go over 2, down 4 to both the left and the right. And we'll draw in the parabola accordingly. This parabola, since it's opening down, has a maximum point. The coordinates of that maximum point are 3, 4, which is the same as the vertex. With a parabola, the maximum or minimum is always the vertex, and we just look at the graph to determine whether it's a maximum or a minimum, or we look at the equation, whether it's opening up or down. The axis of symmetry is, for parabolas that open up or down, the vertical line that splits the parabola into two congruent pieces. In this problem, that would be at x equals 3 as our axis of symmetry. And if we want to solve for the x-intercepts, we could look at the graph, or if we were doing this algebraically, the x-intercepts are where the y is equal to 0. So we would set the original equation, likely the standard form, equal to 0. So we have -x squared plus 6x minus 5 is equal to 0. Now that we have an equation, we can multiply through by -1. And when we multiply by -1, we get x squared minus 6x plus 5 equals 0. This appears to be factorable. X minus 5 times x minus 1. So x would be equal to 5, or x would be equal to 1. The x-intercepts then would be at the points 5, 0 and 1, 0, which align with what we saw up on the grid after graphing this parabola. Next, we will consider our third and final example. This time we have a 4 attached to the x squared, so when we complete the square, we'll factor the 4 out from the variable terms, leave some space, and then write the constant on the side. So when we complete the square, the number that will pair with x is plus 1. It's always half of that number attached to x. When we square 1, we get 1. But what we've really put into this expression is a positive 4. To offset a positive 4, we have to subtract 4. So we have a -1 on the side. And now we have our vertex form for this parabola. The vertex would be at -1, -1. It opens up, and we're multiplying the y coordinates by 4, or vertically stretching them by 4 with this graph. We will draw in our axes so that we have -1, -1 as the vertex of the parabola. It's opening up and we're multiplying by 4, so we need more room to go above the axis on this graph. Label our x and y axes. We'll go to -1, -1, put a point. Then we're going over 1, up 4, since it's a vertical stretch of 4 here, vertically multiplying by 4. And normally we would go over 2, up 4, But in this case, we're going over 2 up 16, which is above what we have on this graph. So for the purpose of this video, we're just going to draw in the portion we have and make it clear that it's a fairly steep graph. There is a minimum point because this parabola is opening up, and that minimum point is at -1, -1, which is the vertex. The axis of symmetry, again in this case, would be the vertical line that splits the parabola into two congruent parts. That will be at x equals -1. And if we wanted to solve for the x-intercepts of this parabola, notice they are not going to be at integers. If we wanted to solve for those specific x-intercepts, we could always go back to the standard form equation, set it equal to 0, and solve accordingly. 0 equals 4x squared plus 8x plus 3. Does this factor? Maybe. We could try 2x and 2x. If we had plus 3 and plus 1, this would get us 4x squared plus 6x plus 2x would be the plus 8x plus 3. So on the one hand, x would be equal to -3/2. On the other hand, x is equal to -1/2. And for x-intercepts, the y-coordinate is always 0. It's where it crosses the x-axis, which is where the y-coordinate is 0. As we look back at the graph, those appear to be the places where the graph crossed the x-axis, -1/2, 0, and -3/2, 0. So keeping this in mind, we should be able to complete the square, to graph our parabola, determine whether it has a maximum or a minimum point. It's where the vertex is. Determine its axis of symmetry, basically the x-coordinate of the vertex, and then calculate any x-intercepts.